to be 2.5 Newton, and we found y2 to be 8 point. Two forces, 5 Newton and 10 Newton, at an angle of 30 degrees and 60 degrees in the direction of x. Use complex numbers to find the magnitude and direction of the resultant force. Now, in case of complex numbers, just the case in vectors, use the parallelogram law. You have to determine all the x components of the respective forces and the y components. Then the resultant force is, the resultant x component is the sum of all x components, isn't it? Yes. And the resultant y component is the sum of all y components. So if you say let Z to represent the resultant force, then we have Z to be equal to Z1 plus Z2, where Z1 we use to denote the first force of 5 Newton acting at an angle of 30 degrees. So in complex number, Z1 is in the form R1 angle theta 1, which is your R there you've been told is the force. So instead of R, we now use F to represent the force. Are you seeing that? Yes. So the first force there in polar form is F1 angle theta 1, where F is the modulus and the theta is the argument. So the modulus is the force itself, isn't it? Yes. So from there we come, this one is 5 Newton with 30 degrees. Now for us to get x and y component, we have to express this force in the form x1 plus y1j. Are you seeing that? Yes. So we are looking for that x component and the y component of that force. So how do we determine the x component? X component is given by the cosine ratio, isn't it? So x component is, if you had in complex numbers, you had z to be, if z is r and the same as z is r exponential j theta. This is the same as r. What is exponential j theta? Exponential j theta is cos theta plus j sin theta. So that means you have r cos theta plus j r sin theta. So if this r is force, then what do we have there? If r is force, then we have f cos theta plus j f sin theta. So that is in which form? It is in the form x plus y. Are you see that? Yes. So it means the x component of any force is the same as f cos. Are you see that? Yes. And the y component here is the same as f sin theta, isn't it? Yes. So from there, you can now see if you want the x component of the force, it is the force itself times the cosine of that angle giving it the direction, isn't it? Yes. So what do we have with the x component there? Substitute. Your force is 5 Newton cos 30 degrees. So what do you get to be x1? 5 cos 30. 4.45. 5. Then you go to the y component. You see the y component is given by the sine, isn't it? So y component is f1 sin theta, and your f1 is 5 Newton sin 30 degrees. Would you get to be y1?
2.27.
My friend, sin 30 is 0.5 degrees. It means that the value given as here is wrong as well. 2.5, yes. This one is 4.330. 4.330. Yes. So your value must be D because we are working with the degrees, not R for radians, or pi radians. So y1 is 2.5. So we found x1 and y1. Now we go to z2, isn't it? So if we have z, so we found, if we have z Z to be equals to F and the theta, then Z2 is F2, theta 2, isn't it? Are you seeing that? So you start. What is X2? The cosine, isn't it? The X component is dealing with the cos. So it is F2 cos theta 2, isn't it? This was theta 1. Theta 1, severe. So F2 cos theta 2 we have. What is your F2?
Yeah.
F2 is 10 Newton, isn't it? Then cos, what is your theta 2? 60 degrees. So when you get to the X2, 10 Newton cos 60 degrees, you have 5 Newton, isn't it? Are we together there?
Yes.
So all these forces are in Newton, isn't it? Then you move Y2 is with the sine ratio, F2 sine theta 2, isn't it? Which is, what is F2 sine theta 2? 10 sine 60 degrees, which you found to be 8.66 Newton. So you see, we found all the X components of the forces and all the Y components of the given forces. So the X components, we found X1 to be equals to 4.33 Newton. We found X2 to be equals to 5 Newton. We found Y1 to be 2.5 Newton, and we found Y2 to be 8.66 Newton, isn't it? So after we found all the components of the force, we now want the result Y1 to be 2.5 Newton, and we found Y2 to be 8.66 Newton. This is the resultant force, isn't it? So how do we determine the resultant force? We determine the resultant X component X, isn't it? Because we say Z to be Z1 plus Z2. Parallelogram, you add all of them, isn't it? You get the resultant force. So here, the resultant X component means will be X1 plus X, isn't it? Yes. You are separating the real part of the complex number and the imaginary part of the error, isn't it? So what is the resultant X component? X1 is plus X2? 5. So you have 9 point. So you found the resultant X component, isn't it? Move to the resultant Y component is Y1 plus Y2, isn't it? So Y1 you found to be 2.5, then Y2 you found to be 8.66 Newton. So what do you get there? 11.16 Newton, isn't it? So after you found the resultant X and Y component, you know Z is in the form X plus Y there, isn't it? Yes. So if you substitute, you get X is 9.33 plus Y is 11.16 Newton. Are we together? Yes. So we've used complex number to determine this resultant force. Now this resultant force, we now want to express it in polar form, isn't it? So in polar form, the magnitude of the force is the Pythagoras theorem, isn't it? Meaning Pythagoras theorem, if you had a circle like this of radius that and this point xy, so here is 90 degrees y x, then it will be r squared is equal to x squared plus y squared. So if r is force, then the resultant force squared is x squared plus y squared, you find the square root of both sides, isn't it? Yes. So the resultant force F is going to be what? The Pythagoras theorem of the x component of the force, which is x squared, that is F is x squared plus y squared, isn't it? So what is your x? 9.33 squared. Y 11.16 squared. So what is the resultant force? What do you get to the resultant force? $14.55, isn't it? Then what did we say? How do we get the direction, theta? We were getting the direction with the tan inverse of y over x. isn't it? Then, here, you don't directly follow the case in trigonometry. So what is tan inverse of y over x? What you do is this. You check the resultant x component and the resultant y component. So you see the resultant x component, if you have Cartesian coordinate system like this, you see the resultant x component is positive, meaning it's in the positive axis. So you see that? Yes. And the resultant y component is also positive, meaning on the positive y axis. So it means the resultant force is in the first quadrant. So it means the angle you are looking for is the angle which is in the first quadrant, because when y over x, what is y over x? That is tan inverse of 11 over x is 9.33. So you can see this is positive. So tan is positive in two quadrants, but we are not interested in the angle of those two quadrants where tan is positive. We are interested in the case where the direction where that complex vector lies, the resultant complex vector, which we found is in the first quadrant. So we want the angle in the first quadrant. So what's the tan inverse of that? What's the tan inverse of 11.16? 50. Divided by 9.15? 50.1. 50.1? From 1 0, just 0.1 degrees, isn't it? Yes. So you found the magnitude and the direction of the resultant force. You can see the direction is 51.1 degrees, isn't it? Yes. And the magnitude is 14.55 Newton. So that is in the form R formatted how to present complex numbers in polar form, isn't it? So that is magnitude is 14.55 Newton, comma, direction is 50.1 degrees. So that is how to determine the magnitude direction of a resultant force using complex numbers. The best way to confirm this, when you want the magnitude, you simply go to the calculator and you say, for you to get the magnitude and direction, you simply come and say that the polar form of xy. So you go to the calculator and you write here, this is what you do, the simplest way. You found the resultant x. After you found the resultant x, you found the resultant x by adding x1 plus x2, which you found to be this plus this, you found to be 9.33 Newton, isn't it? And you found the resultant y by adding y1 plus y2, which you found to be 11.16. So you can see x and y, those are Cartesian complex numbers, isn't it? Yes. Then you now want the polar form, because the polar form is what is giving you the direction, where r is the magnitude and the theta is the direction, isn't it? Yes. So you simply go to the calculator to say what is the polar form of this Cartesian coordinates, isn't it? So can you go to the calculator and find the polar form of 9.33, 11.16? Then you'll be able to get r, which is both giving you the resultant, the magnitude of the resultant force, isn't it? Then you find theta, giving you the direction of the resultant force. So what do you get? Polar form of 9.33, 11.16, 14.55. That is r, severe. So r is the f, isn't it? Yes. 14.55. You cannot get it with the calculator with ES. MS cannot get it. MS will give you one value. MS will only give you the R. It will not give you theta. You use ES. So ES is giving you theta to be 50.1 degrees. So that's what I'm saying. It is ES we are using here. The MS cannot do that. Are you together there? MS cannot work out that. Go for the right calculator. So that is how to determine the magnitude and the direction of a resultant force. Then part B, what have you been told to find in part B?